Hello, everybody. Thank you for joining us today for our Introducing CNC Equipment into the Engine Machine Shop. I am Amanda Harmoning. I am an admin assistant here with AERA, and I will be moderating today's event with my colleague, Rob Monroe.
Hey, everyone. Yeah, Rob Monroe here. I look after membership and technical development at AERA. I want to welcome you to today's webinar with Cass Choate. What I'll do right now, I'm going to bring Cass Choate on from Choate Engineering Performance. And Cass runs both a machine shop and mechanical facility out in Bolivar, Tennessee. And for those of you that have been on our YouTube channel, Cass has done some of the Ford 6.0, 6.4 videos, as well as the 6.7 webinars that we've got. And he does a great job on those. Cass is a wealth of knowledge. We're really lucky to have him on today. He's a super busy guy. So if you got any questions for Cass, again, just put those in the questions box and he'll get those answered at the end. So what I'll do is I'll quit talking and I'll let Cass do the talking. So how's it going today, Cass?
It's going great. I think I've already messed up so fast. I mean, how can somebody screw up right off the bat? I think I clicked the show my screen, and I'm not sure which screen that you're able to see right now. I meant to click the drop down, but
well, we're looking at your reasons why 7 CNC is best. We're looking at that screen there.
Yep. Okay. Well, that's exactly what I wanted to say. Greatly appreciate y'all having me on. As always, it's a pleasure to be able to kind of present and show some of the things that we do here at Choate Engineering Performance. And I'm going to move this over and I guess expand that. So, but anyways, so I want to kind of go over everything with you guys on CNC machining and why it may be the best choice for your shop or maybe not. And you know, I kind of want to break the misconceptions that are out there. I know when I was starting my shop, you're trying to figure out maybe should I go and invest $250,000 into a CNC machine? What advantages, what kind of return on investment should I expect? And when anything like that kind of comes up, you're trying to diversify as much as you can to obtain as much profit through the door that you can. So there was really nothing out there for me to be able to kind of see the different angles of these things. And because of that, it was a learning experience and a huge learning curve. Now, I don't have any affiliation with any engine machining manufacturers, CNC manufacturers. I'm not here today to sell you on Rottler or RMC or whoever it might be. I just kind of want to present the facts that I've found that I wish somebody would have came to me and given me. So the first thing I want to do, obviously, is go over the 7 reasons why CNC machining might be the best fit for your shop. Let's see, I'm going to go ahead and share that with you on the screen. I've got a couple of them up going here. So, but anyways, there we go. So a little bit about us. Obviously, my name is Cass Choate. I am the owner of Choate Engineering Performance. And what we basically do is our shop has a little bit of a niche. We are engine manufacturers. And not only that, we design parts that fix problems with certain platforms. So that being said, a lot of times we, you know, as an engine machining company, as a machinist, I'm constantly seeing things that are in teardown failing, and I'm looking for things that I can do to permanently fix these problems. So that kind of led me to the normal progression of our company was, you know, I started out as a mechanic, had trouble with, you know, getting good machine work done. So then I went into the engine machining side, and then from the engine machining side, I was having again trouble with aftermarket parts or that lack thereof, or possibly quality. And so that led me into CNC machining. So that's been the progression of our company. Since then, we have obtained contracts through Department of Defense, and we've got other contracts from, you know, transmission manufacturers, or even our latest, some stuff from another company that kind of does what we do through Harley Davidson, accessories and different things like that. So it's given us a broad scope of things to do and keep our shop busy. So the reason why it was named 7 reasons why CNC is best maybe is because it really takes an evaluation of your shop. Obviously, if you are a guy that's getting ready to retire and you are not going to be staying in this business much longer, making the investment to spend $250,000 into a CNC might not be the right choice for you. If you are, a guy that's just a one-man band shop and you're turning out enough work, you're not really looking to expand on some certain things, or you decide that the technology might be more than what you really want to delve into. CNC may not be the best fit for you. But here are some of the advantages that I've found by using CNC. Obviously, we know computer numeric control. For anybody that doesn't know what CNC means, that's what CNC abbreviation stands for. One of the biggest problems, and it doesn't matter what shop I talk to, whether it's a shop from a mechanic shop or a restaurant these days, it doesn't matter. The biggest problem that everybody has is trying to find help. That has just been an absolute nightmare ever since the days of pandemic, which it existed before, but it only became worse as the pandemic kind of came through and COVID and getting everybody back to work. So first thing, especially for a guy that's selling engines, that has got customers that have expectations, and you have people that are either out sick or people that aren't necessarily the most dependable, it's really difficult to run a business, and it's extremely hard to satisfy a customer. So you're only as consistent as your most inconsistent person if you're dependent on them. And that's kind of scary sometimes, especially when you're the business owner, because you're the guy that's going to get the chewing. You're the guy that's going to get the bad review. You're the guy that's going to get blasted on Facebook or social media or whatever it might be. So being able to be consistent with your production is a tremendous attribute to CNC machining. And I say that because, it doesn't get sick, right? It can break for certain, but as far as the consistency between a CNC and a person, obviously there's a lot to be said for that. So production stability. If I were a person that was considering spending this kind of money and trying to make this kind of investment, one thing that I would definitely consider too is other ways that I could increase my productivity, because ultimately one reason why there's one main reason why guys look at CNC, and that's to increase production. Okay, so there are other things though that I could do that are a lot less investment, and I'm going to just throw this out there as a plug, that they're a lot less investment that won't cost me near as much that I could increase productivity on. So before I went to spend $250,000, mind you, I would be considering some things that I could do to lean the company out. Now I know that the topic today is 7 reasons why CNC is best, or maybe not. But you can definitely do a lot of cleanup in your company and become more productive in just some, lean manufacturing. And it doesn't mean that if it's lean manufacturing, that it has to have anything to do with machining a block. Sometimes it's just the start to finish of the process, from the time the customer calls to the time he comes and picks up his block or whatever it might be. So those are some things that I would consider, and I think that would merit its own video alone, or its own webinar alone. So moving on from production stability, because we got a lot of things to cover today, is repeatability. Repeatability is being able to have good fixturing. Fixturing is everything in machining. The amount of time that you spend setting up the job that's where you spend. And there's an old saying in manufacturing that fixtures make money, and that's so true, because if you build a good fixture, there's a couple of things that happens with that. You can go from taking, you can take the most uneducated guy in the shop, right, the least experienced guy in the shop, and if you've got a good fixture that works every time, you can put that guy on that particular machine or that process, because now Henry Ford used to say, we don't take the skill out of the work, we actually put it in, and it depends on which side of the skill you're looking at, because the truth of the matter is they did, in my opinion, take the skill out of the work. When you build a fixture, the guy that builds a fixture, well, there's your skill that he's putting into it, but the guy that comes behind him that's doing the job, well, you're making it pokey yoke, where it's one way, you can't do it one way. So it's hard to mess it up, right? So fixturing is definitely where a lot of money could be made because of productivity. So that goes along with something else before I get too far down the road. So what should we look for if we're looking at CNC equipment? What kind of machine should we be buying? Should we buy a Haas? Should we buy a Kuma? Should we buy RMC? Should we buy Rottler? What's the purpose of it? Well, you can do everything on any machine that you want to, so long as it can withstand the weight of obviously the restraints of the geometry of the part. But the thing that you get with some of the engine machining companies, that as you walk through the door, they're already building that repeatability package in with fixturing. So you automatically are buying a package so that you can go to work the first day that the first day the machine hits the floor. So you've got your locators for your mains and your locators for your cam bore housings and different things like that, your cam tunnels, tail stocks. You can go out and you could buy an Akuma or a Haas or whatever you want to put, Mazak, but you're going to have to build all that fixturing. So where does that really come in? Where am I getting my money's worth? Can I, is it honestly, certain companies, like we mentioned, aren't really in the CNC business. Yes, they sell, that's the conduit, how they get to your door. But the truth of the matter is what they're in is they're in a package business where they're building the fixturing. They're putting you in business to be able to do these things. So that's definitely helps with repeatability with fixtures. So that's something to consider there. Because I know a lot of guys will come out and say, well, you know what, I can buy a Haas for X amount of dollars versus a Rottler, and it's a lot cheaper for me. Yeah, but the difference is you're buying something that's turnkey. So keep that in mind. Accuracy is another thing. Now there are guys, it doesn't mean that CNC machining is better in the way of accuracy, because of poor repeatability, you got poor fixturing, you're going to have a poor outcome every time. So just because you own a CNC machine does not necessarily mean that you are better or you do a better job than anybody else. What it does mean, though, is if you do have good fixturing, what happens is that your accuracy is it's consistent, because it doesn't matter who's there doing that job that day. I can take a Renishaw probe off of a locator or a dowel or a known datum somewhere on that block, and I can machine everything back to what I want it to be very, very quickly, versus setting something up and then manually dialing it in through some dial indicator or something, some apparatus of that nature, to be able to tweak the block in. So this is really nice, because the accuracy to be able to blueprint bore something happens rapidly. And if it's something that I learned a long time ago, is if you want to find out where the hangup is in your company, find out where the burden is. Find out the job that you absolutely hate to do the most, and that's the job, you hate it for a reason. Now that kind of goes back to what I said before about CNC machining. And should we start there first, or should we start somewhere else in the company and start working? But if you find the burden of the company, the part, for instance, I hate picking that block up. I'm using a cherry picker to move this thing over and put it in the machine, and every time I do, the legs hit the table before it goes. It's just it's a mess. It's a lot of trouble. Or that cylinder head, moving it on and off. By using some type of lift mechanism, putting that in, you're easing that burden, and by doing so, it makes that job that much easier, which in turn makes it more productive. On the flip side of the coin about accuracy, going back to CNC, is that if I can get that datum dialed in very, very quickly, that eases that burden. So that makes me a lot more productive. Obviously, lower man hours. That's just, that's the obvious. It's not that you necessarily could take a person that has an F2 boring bar and a guy that has an F69, which is a CNC from Rottler, and you put them side by side and you go, which one's going to bore this block faster? Well, it's not that it might just blow them out of the water with the CNC equipment. However, what it does is it allows that guy to not be there and go do something else. So you ultimately can get 3 jobs done in the same time that it takes 1 job to be done. But if you're only doing a time study or an analysis off of that 1 job and not the whole picture, you're really hurting yourself there, because there's a lot more. I can't stand to see a guy that's over there watching a block being bored, just standing there at the machine. There's no reason for that thing. It's going into a round hole. We're not reinventing the wheel. It's not that difficult. The thing's going straight down to the Z-axis. Nothing's really going to change. Go do something else. The machine's not going to fly away. You don't have to hold it down. But it's nice to be able to say, okay, well, while he's doing this, I can be line honing this block and I can be honing this other block. And so I can do multiple operations at once. And that's stating the obvious. Depreciation is another thing. If you're a shop that in a service business, a lot of times what you wind up running into is you get hit hard with taxes. I mean, you don't have a lot of depreciation when you go see the tax man at the end of the year. So if you need a write-off for something, I mean, CNC equipment under the administration of Donald Trump, it allowed for the complete write-off of any equipment that you purchase. It doesn't have to be CNC equipment, but it certainly lends itself very well for that if you need that depreciation. And you can take that in one lump sum, or you can actually extend it over the course of years. So another thing is if you're everybody is into social media these days. I mean, somebody just heard about us. He's a big YouTube influencer, and they called us the other day wanting to do a video. He had his engine that blew up, and so he's going to be sending the truck down, and we're going to be doing like a 4-episode deal with him and getting his truck back up and going. Now, marketing is a huge benefit. Obviously, it's necessary for any company, but you need to use, and that means if you have an engine dyno or you have CNC equipment, or whatever it is, you need to use all the resources that you have in your arsenal to be able to promote your business. One of the best things that we've seen is when somebody says, I have CNC equipment, people will watch CNC equipment run all day long. They're fascinated by it. Funny story, I was at PRI one year, and this had kind of put me in touch with how few folks actually really understand what is going on. The guy came up to me, and I'm running a piece of equipment. I'm running a mill for the guys at Roller. And anyway, the guy comes up, he pokes his head in, and obviously it's a 4-axis machine, right? But the thing's got 2 doors, and then it's got one door in the front, and it's got 2 doors on the side of this machine. And the guy goes and he looks at me and he kind of puzzles and he says, is this one of these 4-axis machines or no 3-axis machines? I go, actually this one's I said, this one's a 3-axis. He goes, this is a 4-axis. I said, he kind of looked at it and the way he said it, I go, no, this one, see that door over there and that door over there, and this one has 3 axes. He just kind of looked at me. He didn't know exactly what I was saying, but the marketing for the company, though, going back to that, is huge because people will associate your brand with quality because you've invested in your company. You've invested in the end product, and you've invested to make sure that the customer has the best quality product that they can have when they leave your shop. Now, the last thing is the thing we're going to spend the most time on, and I'm going to try to speed up here, but flexibility in production. Now, what does that mean? Here's the catch-22, I think, that a lot of people really get caught up on. Most of the time when I talk to a guy and they call me or they ask me, what kind of machine should I buy? I think I'm just going to buy a porting machine. I'm going to go out, I'm going to buy, I think I'm going to buy something that can do cylinder heads, get a centroid, and I'll do cylinder heads, and I'll port, and then I'll do block work, and I'll do this, that, and the other. And I was the same guy. I did the same exact thing. I said the same thing. And a good friend of mine, Daryl Ehrlich, said, you know what? You really ought to think about where you're making your money. And then you need to hone in on that. Because if you have a machine that's not staying busy and you have all these different operations, you're going to spend more time in fixturing and setting up than you are making money. So buying a porting machine, that's fine. If you're going to do enough head work to keep it busy, then fine, do that. If you're not, then you might want to consider something else. But it's like a Swiss Army knife. It's great that it has scissors and toenail clippers and whatever else you want on them. But the truth of the matter is if you're going to cut something, with scissors, you're probably not going to go out and pick up the Swiss Army knife and go, man, these are the best pair of scissors I've ever had. No, anything that does a whole lot of something never does anything very well. Double-minded man's unstable in all his ways. It's Bible for you. But if you have a whole lot of different things that this machine can do, it generally never does one thing really, really well. Not to say that, and if it does, then the other thing is that you aren't making the full potential out of that piece of equipment that you possibly could. So here's a couple of 2 different ends of the spectrum. Okay, so we got 2 different machines here. We've got Rottler on the left-hand side and obviously Haas on the right-hand side. Now, what kind of equipment do you need? And this is a really good question that you need to ask yourself, because most of the time, if you're like me, I thought, okay, I'm going to buy that F69 or EM69, and when it's not busy running blocks, I'm going to go over, I'm going to make parts on it and keep it busy that way. Well, there's two things that you need to consider about this. One of which is that, are you an engine machining, business? Is that what your bread and butter is? Because you might be losing more money trying to make the parts. Two, is that the right machine for the job? Now, can I make anything on either one of these machines? Yes, we absolutely can. But some are better suited than others for certain things. The manufacturing for engine machining versus part manufacturing is vastly different, okay? And no one ever told me this, but a lot of times companies will package something together and go, man, this is a do-all, this is what you need, and then send you on your way, and you don't really find the fine details out until later. Now, one thing that you want to really at this point in time consider is, what is the ultimate goal? 90% of the time, what's this thing going to be doing? Now, there's something called look-aheads on machines. Now, what that means is the machines read G-code, okay? That's just a language that CNC operates off of, just like a program for your computer or any other code, if it's C++ or whatever, but that's what the CNC runs off of. But it has to read thousands and thousands and thousands of lines of code as it's going through with each movement. The machine has a certain capability and capacity to read that line of code at a certain amount of time, okay? So it's looking ahead to see, okay, if it's rapiding and it's got to make a hard turn, it needs to look ahead several lines of code before it ever gets to that point, so that if you don't have good look ahead, what happens is the machine becomes very jerky, okay? And if you see some of the older equipment and some of the equipment maybe that's used in other manufacturing that's not part manufacturing, you'll see that it's very jerky in its operation. Now, there's things that we can do to help some of that. I don't know if any of y'all are familiar with the term point spline, but point splines are basically, if you were to make a radius on an arc, that's how many points that machine has to look at before it makes that arc radius. Now, you can program so that you have less points, and that helps those machines to run more smoothly. But that's a big hang up. Now, the flip side of the coin going on, there's strong suits to both. Again, that package, being able to buy the fixturing. And one of the major things that I see, now, if you're looking at the left-hand screen, you see H85AX and you see an EM69. One of the things that really, really help on our side, we use this equipment, is because the interface is the same. Now, one of the biggest hangups you're going to find as a shop owner is that learning a lot of different types of controllers are going to be very, very difficult. Now, even guys on the part manufacturing side will either stick with a Fanuc or a Siemens, or a control that they're very familiar with, that their guys are familiar with, because crashes tend to happen more when guys are unfamiliar with their controls, or there's a huge delay and a lull or a lag in training guys, trying to get them on and get them comfortable with using that different controller. So the nice thing about some of the equipment that Roller uses is that same interface from the EM goes over to the H85. So the rapid buttons are they're green buttons, the same things are the handle jog buttons are blue. They interface very well together, so it takes a lot less time for me to train a guy. Once he's learned on one machine, I can kind of move him around the shop, and although he may not know it right off the bat, he is definitely more comfortable and he learns a lot faster. So that's something else to take kind of into consideration there. So what I'm fixing to do is I'm going to show you about a 5-minute clip of a Rottler video, and this is no plug for Rottler. Like I said, I'm not getting paid off of them, and I'll tell you the pros and cons of the things that I like about certain equipment versus others. But we're going to go ahead and click over that. So Amanda, if you can play that for me, I appreciate it. And I'll just be quiet.
Yep, no problem. I'm just gonna hit play on it here. And before I do, I just want to remind everyone, this does play through computer speakers. So if you are listening in on your phone, you may have to unmute your computer to hear anything that may be in the background.
Okay, and we're back. Okay, so quick thing about that. Obviously, we were asking is CNC for you. Now, keep in mind that's $400,000 worth of equipment. Let's just call a spade a spade. That's expensive. If you're running that much of the same head, then that might be the way to go for you for sure. But if you're a one-man band, a small shop, maybe that's not necessarily the right machine. Now, I will say this: there's a lot of different options. They're showing a fully automated seat and guide machine. So that's really nice because we do a lot of the same heads. So that would be very beneficial for us. Now, keep in mind, everything that we've gone over has been to this point has been engine machining. Okay, so now let's switch gears because this stuff I feel like gets covered a whole lot. Everything that we've done heretofore has been pretty much covered. So what I want to show you what we do in the shop and how we kind of balance between the two. Now let's switch gears. Now let's go into part manufacturing. So Amanda, if you will, let's play this next video and I'm going to kind of voice over a little bit. So quick thing about that video, you can, let's see, we have got, so a couple of things that were going on with that. You all obviously saw their simulation in the first video. So that can tell us obviously if we're going to crash or anything like that. That's a 5-axis machine. It's machining out an oil pan. What I want to do quickly is kind of run through the entire process, because if you're like me, and you're trying to you're trying to find out how can I get from start to finish on making parts? What is that going to entail? What all do I have to learn? What all do I have to buy? What are all the steps? So this is what we do in our shop. So Amanda, if you will, I was unable to unmute myself on that last video. I don't know if there's a way that we can do that when we show this next one. But if you want, we'll go ahead. What we're going to do right now is show a 3D scanning video, and then I'm going to walk you through basically a part that is that oil pan that we just did, and show you what actually has to be done in order to be able to recreate that or to machine that. So we'll go ahead and I'm gonna, Amanda, if you will, go ahead and show me, you can go ahead and start. Okay, so this is in our lab. So we have a roamer arm. There's lots of different arms out there. The thing that makes 3D scanning really, really handy, obviously, is that you can pick up data very quickly. And now, I don't want this to look like a cooking show, okay? Because that was one of the first things that I wanted to explain when I was talking to Rob. I was like, there's so much bad information out there, and people make things look a lot easier than what they are. What we're doing here is creating or obtaining point cloud data. What that means is that it basically it's kind of like when you're a kid playing with that what was it paint by numbers. So what it does is it's collecting all these points in space where the part is, and it's creating what is seemingly a solid object, but it's actually not. So it is a mesh file or an STL. Now, guys that like 3D printers, you're very familiar with STLs probably already. For you guys that are into engine machining and that aren't into that kind of stuff, basically what it means is it's triangulation. It's a bunch of triangles that are put together so that a solid object is, like I said, seemingly obtained. It's not watertight, so it's not machinable. And drag here. All right, so basically this is a pan that we scanned in, just like you saw in the video. So what I do, my job in the company is pretty much to design new parts. The nice thing about this part is it's scanned in. You can even see the imperfections. That's not the scan data. that's actually the that's it, imperfections in the pan. So we'll scan this in, and we can come along and create a mesh sketch. And by creating that mesh sketch, what it'll allow us to do is to hope everything's good there. It'll allow us to pick up data points on the object that we're trying to reverse engineer. And in doing so, we will take this information, and once we have completely reverse engineered this into a solid model, then we'll take and move that in to my design phase. So we'll import it into a different software. Now I'm using this software here because it's actually very, very obtainable by, it's free to anybody if they're not using it for monetization purposes. So I've taken this, and obviously you can see this oil pan's been changed completely, but it started out with the data points. Now, one of the interesting things about it is that it allows me to see something that I wouldn't have seen before. I can do a section analysis on this, and through 3D scanning, it allows me to see that there's a taper in that pan, which is an important part to understand for the pickup tube. Once we take it from here and we've created this solid model and we've manipulated it as we would have it to be, we can take that same solid model and build a fixture for it, which is what we've done here, and put clamps in. We can import the clamps like we want, so that we can make sure that when we machine this, it's exactly how we want it to be, and it sits in the pan or in the fixture just right. So once we create, so now we've 3D scanned everything, we've got our STL file, we came back through, we created an IGES or a step file from it. We've imported it into our software for reverse engineering, or excuse me, for design. Then what we'll do is we'll take that same model and move it over into, I think, Amanda, I don't know if you're muted or not. We'll move it in over to the CAM software. So there's CAD and CAM. So CAD stands for computer aided design. So that's what we did in Fusion. And then there's computer aided manufacturing, which is what we're going to do here. So we take this part and we can create a block and see from that block what our machine is going to look like. And we can create tool paths to come in and machine. Now, because I started it where I did, it actually shows a gouge. But anyways, we can come in and we can go ahead and machine this part and see what it's going to look like when we get done. Now, all these things can be done on your engine machining CNC equipment, okay? Some machines, again, lend themselves a little better to these things than others because, again, there's a tremendous amount of code that you would see. And to kind of give you an idea of how much code, let me see, I can stop this and I'll just look up here in NC program. And let me see. Okay. And we'll write this code out. Now, all those things are things to take into account when you are purchasing a CNC equipment, because that is a tremendous amount of code for this machine to read. So let's see. And let me click in here. Sorry, guys. It takes me 1 second. So this is all the lines of G code that this machine has to see, okay? And you can see on the right-hand side, it just goes for miles and miles and miles. So it has to look ahead and see all this line of code as it's machining. If not, like I said, it gets very jerky and it gets very difficult for the machine to process. So picking the right machine is very important. But all those things, like I said, can be done. You can do this with equipment that is, that an engine machining company would manufacture. So I hope that kind of gives you a little bit of insight as to what we do and what can be done with your equipment. And if you're trying to make that leap from engine machining into part manufacturing, that's a big jump, but it definitely can be made. But you just really need to go in and figure out what is going to best suit you. And I'm a little trouble with my screen. Just a second. There we go. So I hope that kind of gives you some insight as far as what CNC manufacturing is going to look like compared to engine machining. There's a lot that goes into that. And if a person is trying to get into that or already has a machine, but they don't really want to get into the programming side, they don't want to get into the reverse engineering side or anything like that, you can actually reach out to us. We do programming for other companies as well. And we just need to know the type of machine, your tool crib, and things of that nature. We've got some questions that we'll need to ask you and some files that we'll need to share. But you can contact us and we can help you with that as well, so that the part can be manufactured right there in your own shop. But anyways, if anybody at this time has any questions, Amanda, we can go ahead and open it up for any questions that some of you might have.
Super. No, thanks, Cass. Really good presentation. You answered a lot of questions. I know there was a lot of folks that were probably on today, just sort of, trying to make that decision whether they're going to spend the $250,000 and just what they're getting and that kind of stuff. So you kind of gave us a real world perspective on just what to expect from CNC. They definitely have their advantages, and again, we appreciate your real world look at it. I got a kind of kick out of your one joke there. You were talking about the gentleman that you saw at Rottler about the 3-axis, 4-axis. So really, all Rottler needs to do is add a couple more doors to that machine, and they would have, they don't even have to top up the price. They could just put a few more holes in it, and you're
skill saw. Yeah, you could really increase that. But yeah, it just kind of shows you how out of sometimes just how little is really known about CNC machining. We talk a lot about different aspects of engine machining, whether it's seat concentricity or cylinder finishes on the walls, but actually knowing the equipment is kind of one of those areas that are it's not really been touched on that much. I mean, you're always going to have somebody that's going to try to sell you something, but the real world experience of somebody that goes and says, hey, this is what it will do best, and this is what I would use it for, and this is why I use this. That's, to me, that would be, is really interesting because I find it applicable.
Okay. Sure. No, that makes total sense. Definitely some questions are rolling in, Cass. This one particular person's asking, what is the name of the free software you're using for design?
Okay, great. It's Fusion 360, and so Fusion has they got some really cool stuff, simply because they are a one-stop shop type. It's owned by Autodesk. Autodesk has pretty much gobbled up everybody but Mastercam and a few others. I say that, but they're a very large software, CAD/CAM software. But Fusion will do, now obviously there's extensions and add-ons and you have to pay for some of this stuff that I'm fixing to mention. But the neat thing about it is that you can design it in their CAD system. You can machine it in their CAM system. You can take and put it into what's called a regenerative design, where you can take, let's say, a connecting rod. You're wanting this to be as light a connecting rod as you possibly can do. So you can do stress analysis. So you can do, it has FEA analysis, finite element analysis, that's built into the software. It's not necessarily as good as SolidWorks on some things, but it's very, very powerful. So that's the name of the software. Check it out. You can also 3D print off of it. So if you're a geek that loves that kind of stuff like myself, you can create whatever you want from there and be able to produce code for 3D printing.
All right, super. Next question, Cass, is they're asking, are you self-taught on this level of engineering, or is this from an engineering degree, or what kind of training did you get started with to get into CNC stuff?
I'm an acknowledged fool, okay? So I'm the biggest idiot that you'd ever find. If anybody has, they say the Lord can help anybody, and I'll tell you this: I've certainly handicapped the Lord, but He works well with handicaps, and that's been my it's been a blessing to me because I need it. Everything that I've ever done pretty much has been self-taught, and the reason why I did not go that route is simply because I know what I want to do. I just need to figure out how I want to do it. And we live in the information age, and I don't mean to get on a soapbox by any means, but we live in the so-called information age. But unfortunately, so many folks don't have the information to share. They don't know anything, and sometimes that's because if you want to learn, there's so much out there right now. If you want to learn how to model, Lars Christensen is probably one of the best NYC CNC with I can't think of the guy's name right now, but it'll come to me in a minute. But Lars Christensen and NYC CNC are really, really good. They do a lot of videos on that. So I started watching a long time ago some of this stuff, how to learn how to model there. There's not, I will say this, for the reverse engineering side of 3D scanning, there's not a lot of information out there. So the software that I showed in this video through PowerMill, I found the limitations of Fusion and the 5-axis machining. There's not a lot of information out there, but there are companies that, and you have to learn. It gets more expensive, but you can do a tremendous amount with Fusion that's free, and there's a lot of support there. So I was self-taught. If YouTube University and a bunch of different other places, and calling and agitating people and asking questions and reading books and everything that I could get my hands on, and I still do that. So I use it a lot. So don't be scared.
All right. Cass, next question. What machine did you start with before you upgraded to CNC?
Well, so I actually jumped right in, as far as CNC equipment is concerned. I was a glutton for punishment, always have been, but I wound up starting out, which I think is a great transitional tool. The first mill or block machining piece of equipment that I bought was an F69 from Rottler. It was an ATC, so it had an automatic tool changer. And I thought that was really good because that kind of got my feet wet, because I was unfamiliar with, with most all things at that point. But the machine moves slow, the interface is very basic, and it got my feet wet into CNC machining. Now from there, I moved from there to another 3-axis mill that was, a super speed, like Haas. It can do some things that that the Rottler just did not have the capability or capacity yet to do. And then from there, 5-axis machining, and we do a lot of stuff with live tooling and lathes, 3-axis lathes and things like that as well. But that was my first piece of equipment.
Okay. All right. And you may not quite know the answer to this one. This is a little bit more on a tax question, but they've asked for the tax write-off. They mentioned that their tax guy says that they have to make 100% of the machine costs to write it off. I didn't know if you could, because I know I heard you mention about the write-off there. So again, if you don't know the answer, we can always get more information for this gentleman.
Yeah, I would definitely check with online on that. As far as 100% of the, I'm assuming that he's saying that his gross profit has to be 100% of the machine. I think that's what I'm understanding. If that's the case, that was not my experience. But I would definitely look into that. There's a lot online about that, and you can consult your CPA. But it is. Oh, and one other thing I'm going to throw out there. There are certain things that you can do. Now, this is a big secret that I'm fixing to give away. If you own a piece of equipment and you have a business, and let's say you're trying to train people, you need to check with your state, because it varies state by state, but there is funding that can be had for training. And that is a huge thing for AERA. So let's say, and this is a plug for them, and they're such a great organization, and I'm always there to support guys like Chuck Lynch. Like, if you're trying to get somebody to come out and train your guys, you might check your local and your state grants, because they offer training on site. So there's certain limitations to it. Obviously, you can't train yourself and get reimbursed for training your own employees, but there is certain funding that you can go out and you could use this for training from AERA. So you can get that funding and show that it has to be a company that is a certain size, and it may be 5 employees. I'm not sure. It's state by state, but you can do that and get funding for that. And there's allowances for each guy to be trained, and the state will actually pay for it. So that's something else I just kind of went off on a tangent, but it's a very good tool. So you might look into that as well.
No, good point, Cass. Thank you. Next question for you is, what software writes the actual code the cutting head will follow?
Right. So Fusion will actually write code. Their PowerMill, any CAM software that you use. So the PowerMill was the one that you saw on the video of the 5-axis machining, and the one that I pulled up, kind of showing the block model. That actually outputs or writes. It's a post processor is what it's called. Okay. So you can create a post processor is basically what converts the language. It's your interpreter. Okay. So it's kind of like to put it, in layman's terms, is if someone else spoke a different language and you're trying to get somebody to be able to transfer that into a language that you can understand. So the post processor comes with, like, Fusion has a library of posts, and it comes just automatic. Like if you wanted a 3-axis post for a Haas, so every machine is a little bit different. Like let's say you have an Akuma, or you have a Mazak, or you have something of that nature, or even like a Rottler or RMC or whatever. There are posts, and that is another thing that's a really good question, because that opens me up to something else. You need to look, if you're going to be using something like Fusion that's a free software, and you have I'm not going to mention any names here, but if you have a certain CNC, that is a good question to ask them before you purchase and say, okay, do you provide a post processor that will work with my software? Because if they won't, I wouldn't be interested in buying your machine. It does not do me any good. All it's going to work is based off of the interface that you've already got loaded on the machine. I don't want that. For instance, Centroid, they use a Mastercam for their stuff. So Centroid works with, they have a post processor. So what that does is when you get done doing all your stuff in your cam and you hit write like you saw me do and it generated the code, it has to have that post to go between and go, okay, these are all the things, XYZ locations, the coordinates, Cartesian coordinates, whatever. This is everything we need. And then it translates that into G code. That's a really good question to ask before you buy any CNC machine, and verify that is a good post processor, because a bad post processor will hinder you and limit you to, you won't be able to do anything that you wanted to do if you don't have a good post on it. And if I was looking at that, I might give them a part and say, okay, post, here's my part, here's where I programmed it. Now I want you to post out in code. Let's run it before I buy it.
All right. Cass, a couple more questions here for you. So what type of machine work provides the most company income, in your opinion?
What type of machine provides me the most money? Well, okay, so I'll bust it down in 2 different aspects. And that really depends on the dog you feed, the one that's going to, get the biggest. And what works for me doesn't necessarily work for anybody else. That's just what works for me. Right now, probably engine machining does more as far as bringing in the revenue. We know certain things like blocks don't pay as well, in my experience, as cylinder heads. Cylinder heads are a lot better avenue. If I was going to invest in, and this is the way I think of it. And now we're kind of going into business 101 of a machine shop. But so here's a good way to think about that. If you had limited amount of floor space, which many people do in their shop, and I had to figure, like Kroger does. Kroger doesn't sell groceries, okay? Kroger rents floor space. They rent to, I don't know, what's a cereal company or whatever, Kellogg's. They rent a certain amount of floor space to these companies, and they come in and basically they are just the storefront, and they are the landlord, so to speak. If I was trying to figure out what was going to make me the most money, I would figure it by the square foot. Okay. So I've got 1,000 square feet, 2,000 square feet, whatever in the shop. If I'm trying to figure out where to invest my money, I would figure it out by per square foot. A block takes up more square feet than a cylinder head. Let's just say it did. Then it needs to make X amount of money for me. And then figure that, and you can figure a ratio up by that. And then that would be the way that I would look at it. Now, I may have gone completely a different direction to answer your question on that. If it's more direct, like does part manufacturing make more money than the engine manufacturing? That just depends on how much I pursue the part manufacturing. There's a lot of there's a lot of desire and demand for part manufacturing. There's companies out there like Xometry that do nothing but, they're like, Xometry is a company that if you have a person, you can bid on the part. It's no different than, we use a freight company all the time that, I can't even think of the name of it right now, but if you have a load going from from California to Tennessee, U-shippers, I think is what it's called, Uniship or something like that. But anyways, you can post it online and then somebody will bid that job. Xometry does the same thing, except they do it for parts. If you've got a part that you want made, you can post it on Xometry, and then somebody's going to come along and they're going to bid that job. If you pursue it, it's out there. It's a lot more, depending on the jobs you're getting, there's a lot more competition, but there's also a lot more available, and they can be more requirements depending on what certifications that need to be had. And that all depends on the person that you're making the part for.
All right. So Cass, one more question I've got. Any of the questions that we didn't get around to getting to today, we'll make sure that we send those to you. But we've got one question here. How many hours would you say it takes for someone who hasn't used a CNC machine to become comfortable on it?
Then I would ask this question. It depends on what you mean, because it depends on what you mean as far as getting comfortable with. You mean operation, or do you mean programming?
Well, let's say operation. Let's say you're training someone on the floor to run the machine. How many hours would it take where you could walk away and be comfortable that they're going to be able to not crash the thing or do their job?
All right, so that goes back to what we're saying. If you build good fixtures, and I've got a young guy out there working right now, and hopefully he's not crashing the machines that's up in here, but we'll know in a minute. But I mean, he runs parts for me all the time. But once I set it up, there are so much automation to be had just running a CNC equipment. I mean, I literally could take somebody and within 2 weeks have them very comfortable of being able to load and being able to load a block or a part and run that very, very quickly. There's more to it than just running the machine. Let's say, for instance, okay, if you board a block, then you need to know, is it just running the machine, or does the guy already have some basic kind of GD&T kind of understanding of dimensions and tolerancing and being able to measure that bore with precision and then adjust the cutter so that it comes out to the tolerance that it needs to be? That is by far more difficult for me to train a guy to, set up the setting fixture or tram in the setting fixture, not run the part, or make sure that you adjust the cutter properly. So, if I was going to do something like that, a guy could learn it in a couple of weeks. Now, that being said, I don't want to mislead. If the guy's question was to program, years. To be a good programmer, it takes years. I don't care what anybody tells you. You can make a part, but to get good at it, there's a lot to it. There's a tremendous amount to it. So I hope that kind of answers the question. Clear as mud.
Yeah, no, that's great, Cass. Well, like I say, if we have any more questions, we'll forward those to us, put them in the questions box there, and we'll get those over to Cass to answer. And they're really good at getting back to us. Cass, again, we really appreciate your time. We know you're super busy, and you got Luke in the background just helping us out there. So Luke, hats off to you, man. You kept things going, so I appreciate it. And again, if you want to see any of Cass's other videos, like he has the Ford 6064 and the Ford 67, because he does a lot of those engines in-house. Those are on our YouTube channel, and Amanda's going to show you how to get to there here in just a minute. But thanks, guys. Really appreciate it, and hats off. Really good job.
Right, real quick here, as Rob mentioned, all our webinars do end up on our YouTube channel. You can go out to YouTube and search for AERA Engine Builders or Engine Builders Association. Either way, we should pop up. You can see there kind of what the top of our page looks like, and you'll find some playlists for technical webinars, business webinars, or you can just scroll through everything and find what you're looking for. And then real quick, when you leave today, there will be a survey that pops up. Take a moment, fill that out, let us know how we're doing. You can also put any additional questions you have in that survey. And thank you for attending. We know you guys are busy, and we appreciate you taking time out of your day to tune in and listen to our webinar. If you do need anything from us here at the AERA team, you can contact us via phone at 815-526-7600 or feel free to email either myself or Rob. Both of our email addresses are listed there. So that about wraps it up for us today. Thanks again, everyone, and we hope you have a great rest of your day.